Hello everyone. In today's video we are going to see how the operational amplifier circuits will respond when an alternating signal, nothing but an AC signal, is applied. So in the previous videos we have seen DC characteristics, nothing but with the apply of DC signal how the op-amp circuit will respond, and without applying a DC signal how the output voltage is a non-zero value, that is obtained. Because of what parameters? That with a zero input voltage a non-zero output voltage is obtained, we have seen, and we have discussed what are the compensation techniques that are used in order to overcome the drawback. Now in today's video we are going to see how an AC signal affects the internal stages of an operational amplifier. Okay, so here the AC characteristics, we are having mainly two important parameters. One is the slew rate and other one is a frequency response. In today's video we are discussing about the slew rate and how it affects the internal stages of operational amplifier, what is its expression, and how the output waveform will looks like, and also we are going to derive the equation for the slew rate. Now let us discuss what is a slew rate. So according to the mathematical definition, the slew rate is nothing but the maximum rate of change of output voltage with respect to time. We are calling it as a slew rate. Nothing but we have to find out what is the output voltage. After finding the output voltage, we have to take the derivative of that output voltage with respect to time, and after the final equation, in that we have to find out what is the maximum value. So it defines itself the slew rate. So here S is dV0 by dt, the maximum value, and is expressed in terms of volts per microsecond. So here V0 is nothing but voltage, which is expressed in terms of volts, and T is nothing but time period, which is expressed in terms of second. But the slew rate will be a minimum value for the operation amplifier, that's why it will be in terms of micros. And here whenever a high frequency large amplitude input signal is applied to the operational amplifier, then the capacitors that are present internally in the circuit of op-amp will be charged. But because of a high frequency and large amplitude, there exists a limitation in the charging rate of a capacitor. So this is because of a slew rate. And how we are finding a slew rate relation in terms of a capacitor, that is derived in terms of a current equation. So that is S is equal to I max by C. For example, if you consider an op-amp 741 which is having a charging current as 15 microamperes and a capacitor as 30 picofarads, then the slew rate value will be 15 into 10 power minus 6 by 30 into pico is 10 power minus 12. So it is finally 0.5 volts per microsecond. Okay, so we have to choose a circuit in such a way that the slew rate should be a minimum for the operational amplifier circuit. And that too, the slew rate will be minimum if you consider the time in terms of microseconds. Okay, if you consider the time in terms of seconds, then the slew rate should be maximum. Now we are going to see how the slew rate will affect the output waveform of a circuit. So suppose if you are considering a unity gain circuit, so nothing but a unity gain circuit is nothing but a voltage follower circuit. So which means that the output voltage is equal to the input voltage. Now we are considering that the input voltage is a square waveform. So therefore the output voltage must be a square waveform because we have considered the unity gain circuit. But because of a slew rate at a particular frequency, the output waveform will get distorted. So because of a presence of slew rate in the op-amp circuit at particular frequencies, the output of a waveform will distort. So in order to get the distortion free output, what must be the value of slew rate that must be designed for an op amp? Now we are going to see with the help of the derivation of slew rate equation. So let us see how to derive the equation of a slew rate. Now let us see how to derive the expression for the slew rate. For this purpose, let us consider the op-amp circuit which is having a unity gain. So let us consider this is one op-amp circuit. So this op-amp circuit is having a unity gain. To this I am considering Vs as my input, and to this V0 is my output. Since the op-amp gain we are assuming as unity gain, so we know that from the basic definition, gain is ratio of output voltage to the input voltage. So output is V0 and input is Vs, which is equal to V1. So finally the V0 value is Vs. Now let us assume that the Vs is a sinusoidal signal. Since we are considering AC characteristics, so let us assume that the Vs is a sinusoidal signal, and we know that the expression Vs as Vm sin omega t. So from this equation, we are obtaining the value of V0 as Vs, which is equal to Vm sin omega t. Now we have obtained the V0 value. Now we will derive the slew rate expression from the basic definition. So we know that the slew rate is defined as the maximum rate of change of output voltage with respect to time. So this is the definition of slew rate, nothing but the maximum rate of change of output voltage with respect to time. So from this we know that what is the value of V0. Let us consider as equation 1. Now we have to derive this equation with respect to time. So let's find out what is the value of dV0 by dt. So it is equal to d by dt of, from equation 1, what is the V0 expression? It is Vm sin omega t. So Vm is a amplitude, nothing but a constant value. So now we have to find out what is the derivative of sin omega t. So we know that the derivative of sin x is cos x, and the derivative of sin ax is a into cos ax. So from this definition we know that derivative of sin omega t is cos omega t, and the derivative of omega t is omega. So this is the value of dV0 by dt. But the slew rate definition is the maximum value of dV0 by dt we have to find. So next step is finding the maximum value of dV0 by dt. So it is Vm omega cos omega t maximum value. So we know that the maximum value of cos omega t is 1. So that's why finally it is Vm into omega into 1. So dV0 by dt max value is nothing but slew rate, which is equal to S, and Vm into omega in terms of frequency if I write, then it is 2 pi f. This is the expression of slew rate. So from this expression we can say that the slew rate is always depends on the amplitude of a voltage signal and also the operating frequency of the circuit. For example, if you want to get a distortion free output, then the frequency should be a maximum frequency of the circuit. So nothing but FM or FH. We can indicate with either FM or FH. So for distortion free output, this simply F is replaced with either FH or FM. So this is the procedure how to calculate or how to derive the expression for the slew rate for this unity gain circuit. Thank you.